function f is defined by f of x equals x e to the power of negative 2x, with the domain of 0 is less than or equal to x, which is less than or equal to 10.
Okay, part A.
Find all values of x for which the graph of x is increasing and all the values of x for which the graph is decreasing.
So for me to find out if the graph is increasing or decreasing, we need to find the derivative and see if it's positive or negative, right? So let's go ahead and write out f prime of x. What rule are we using on this one? Product rule. So we have this separated by this right here. So the product rule was we derive the first one, which is what? 1, and we keep the second one as it is, plus keep the first, and then we derive the second one. The derivative of e to the whatever is that self, and then the derivative of the power. So e to the power negative 2x times the negative 2. Are we okay with that one? Now we need to set this equal to 0, but since I'm thinking ahead, I think I want to go ahead and factor something out. Between these two, what is a common factor? So we're going to pull out e to the negative 2x. So we have remaining 1 minus 2x. So our critical number is going to be when these are set to 0. E to the whatever is always positive. Write that on the side. E to whatever it could be is always positive. So therefore, we can't really find the critical number on that one. Here we go. We could find the critical number here. When we solve for x would be what? 1 over 2. So let's make our number line. On my number line, it says to bound it at 0 and 10. And our critical number we found was 1/2. And we're comparing f to f prime. So if we plug this one into these two right here, the first one is always going to be, actually, let's go ahead and pinpoint out a number. How about we test maybe 0.25? 0.25 or 1/4? And maybe we could test out just the 1. Is that 1 right in between? So when I plug this one in here, no matter what, it's going to be positive. But if I plug in the 0.25 in here, it's going to be another positive. So because it is positive at this interval, the graph is going up. Let's test the 1. E to the whatever is always positive. When I plug in the 1, I'm going to result in a negative. So we have a negative, meaning the graph is going down. Let's write the result on the very top. See if I can zoom. Okay. On the very top, I'm going to say the function is increasing on the interval 0 to 1/2. And you have to give a reasoning. Because f prime is what? F prime is positive. And then we know the function is decreasing on the interval 1/2 to 10. And that is because f prime is doing what? Negative. Are we okay with that part? Okay? My second part. Josh, let's read.
Suppose that the function f has a continuous second derivative of all x, and that f of 0 equals 2, f prime of 0 equals negative 3, and f double prime of 0 equals 0.
Are we on part B? 21B?
Oh, my bad.
That's okay. Let's go ahead and read that part.
Give the x and y coordinates of all the absolute maximum and minimum points on the graph of f. Justify the answer.
So we want all the absolute minimum and maximum of the graph. So go ahead and make your t-chart. The x that we found, I know it is 1/2, but we have to also test the bounds. So 0, 1/2, and 10. It wants the graph of the original, so that's going to be f of x. And our f of x, as a reminder, it is x times e to the power of negative 2x. So let's plug it in. If I plug in 0 times e to the power of negative 2 times 0, that's going to give us what?
E to the 0.
Times 0 is? 0. Let's do the 1/2 then. We have 1/2. And then e to the power of negative 2 times 1/2. And I want to rewrite this without a negative power. So that's going to bring the e down. So we have 1 over 2e. Now you don't really have to compute this. So I'm going to go on to the second part. We have 10 times e to the power of negative 2 times 10. And if I were to rewrite this without a negative power, that's gonna give us 10 over e to the power of 20, right? Okay, which one is gonna be smaller? The top e or the bottom e?
The bottom one.
The bottom one is gonna be very, very small. So I'm just gonna write on here, it's gonna be very, very
Very.
small positive number. Whereas this one is just gonna be a small positive number.
Yeah, the bottom one will be.
So just by looking at that, our absolute minimum has to be at 0, and our absolute maximum has to be at where? At 1/2, good. So let's put on here, our absolute minimum is at 0, 0, because it went an x and y coordinate. And our absolute maximum is at 1/2, comma, 1 over 2e.
Now, what's justification for this?
And then our justifying would be basically our work.
Okay.
That work is gonna be justification. Are we good with that? Okay? For number 22, I may need a separate sheet of paper for part D only. So I'm gonna try to fit everything in here. Okay, let's start by writing out the equation that's given since it's kind of tiny. So it's given that we have g prime of x is equal to e to the power of negative 2x times 3 of f of x plus 2 of f prime of x. Is that what you guys see as well? That's given right here. Oh, that is what I have, right?
Yeah.
And then they also gave us 3 different points. F of 0 is 2. And then f prime of 0 is at negative 3. And then we have f double prime of 0 is 0. Okay, Camille, let's read number 22 in part A.
Write an equation of the tangent, line tangent to the graph of f at the point where x equals 0.
So we need to write the tangent line. The tangent line involves a point, and it involves a slope. Our point is at 0 comma something. Now, if I were to plug in 0 into our point of the function, actually, we don't have to plug it in. Isn't that a point already right here? So we have 2. And then this is a slope at x equals 0. So we know our slope is already negative 3. And y'all remember the y minus y1 equation?
Kind of.
Y minus y1 is 2 is equal to our slope, negative 3 times x minus 0. And then don't simplify, especially for the free responses. Because if you mess up as you simplify,
Then it's all wrong.
then the whole thing is wrong, and you don't want that. All right, part B, Hunter, let's read.
Is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0?
Okay. Let's underline point of inflection. Don't we already have the information about the point of inflection at 0?
Yes.
We already have that? So we know, if I know it, f double prime is equal to 0, is it a guarantee that, that my left and the right is going to be a positive and a negative? Is that a guarantee? Could they both be positive? They could both be concave up or concave down. So it's not a guarantee. So we're going to write no. Even though f double prime is equal to 0, it does not mean that f double prime changes signs. That is not a guarantee at x equals 0. Because things can concave up and continue to concave up,
Yeah.
and vice versa. Okay, let's go to part C. Ashlyn, let's read part C.
Given that g of 0 equals 4, write an equation of the line tangent to the graph of g at the point where x equals 0.
So we already have a point, 0 comma 4, so that's nice. And then we need to find out the slope. So the slope is represented by g prime of 0. And don't we already have an equation for g prime of 0?
Yeah.
Yep, let's plug it in. So the equation is right up here. So we have e to the power of negative 2. Oh, 2 times 0. And then we have 3 f of 0 plus 2 f prime of 0. Let me bring it up. And our main focus is, do I know f of 0 and f prime of 0? Is that given?
Yes.
Yay or nay? It is given. What is all of this no matter what? Any number to the power of 0 is 1. So I see my 3. F of 0 is given as what?
F of 0 is 2.
2. Very good. And then we have plus 2 times, what's f prime of 0? Negative 3. If you were to compute this, what do we get? 0. So now let's write our point slope formula. We got y minus, y1 is 4, is equal to my slope 0 times x minus 0. And just leave it like that. Okay, are we ready for part D? Okay, I'm going to start part D by writing the original equation out. The given function. I'm almost done. Logan, are you with me?
Yes, ma'am.
Okay, g prime of x. I'm writing the original equation out because it's going to ask us to derive it.
Well, that's different.
All right, Luca, let's read part D.
Show that g double prime of x equals e to the power of negative 2x times negative 6 f of x minus f prime of x plus 2 f double prime of x. Does g have a local maximum at x equals 0? Just to answer.
So they're asking us, hey, I'm going to go ahead and give you the answer. So from the original g prime, can you derive it to get to this equation? So they're really in the end grading in between. Does that make sense? Okay, let's go ahead and work on this one. Here's my product rule. Pretty long product rule. So here we go. We have, I'm going to take this out. It's quite messy. Let's write out g double prime of x. Okay, let's recall the product rule again. We derive the first piece, which is what? E to the negative 2x times negative 2. And then we keep the second piece, correct? So copy it as it is. And I'm going to try to do my best to fit everything. Kind of doubt it, though. I'm already, like, all the way to the right. And then the rule for the second piece is plus. I keep the first piece, and we derive the inside. When I derive the inside, I'm going to keep the constant. What is a derivative of f of x? F prime of x. Plus 2 times. What is a derivative of single prime?
Double prime.
Double prime. And then let's see about simplifying further. All of this is being distributed. And all of this will be distributed. That's the annoying part.
Wait, that second part goes to the last part?
What's that?
That the second e to negative 2x?
It goes to all of this.
Oh,
The
okay.
distribution means in the parentheses I have a plus or minus. Okay. So here I have, if I were to multiply all this with this one, negative 2 and negative 3 is going to give us negative what? Negative 6 e to the negative 2x. And then I know we have f of x. Do y'all see how I'm multiplying this? Taking this times this piece. Good? Now we're going to take this one times that piece, which is going to give us minus 4 e to the power of negative 2x. And then we have f prime of x. I might make it. We'll see. And then let's distribute this one to all of this right here. So we have plus 3 e to the negative 2x, f prime of x. Now distribute it to the last portion, which is plus e to the negative, oh, I forgot to put the constant first. What's my constant that I should write first? 2. I guess it doesn't matter, but I kind of want it neat. So we have 2 times e to the negative 2x, f double prime of x. Is there a combining like term anywhere?
Everywhere that there is no. Yes.
Do I have something that is identical?
E to the 2x.
Do you see that this is identical as this one? So can I combine like terms? Yeah, let's do that. Did someone say minus 1?
Yeah.
That is correct. Then we have the last portion. It's just quite tedious.
Yep, definitely.
All right, let's factor something out. What is common between all of these?
E to the negative 2x.
They all have e to the negative 2x. Let's factor it out. And write the remaining in the inside, and I think I wanna use a bracket. We have 6 f of x remaining. We have minus f prime of x remaining. And then we have plus 2 f double prime of x remaining. Oop. Okay, let's compare this to what they asked us to find. Did we get what we see on part D? Yeah? So we just proved it. And then part D says, now find what?
Oh,
What the value of x is. When x, or
does it?
when given the x is equal to 0, right? So let's plug it in. We have g prime of 0. I'm just gonna put e to the power of 0. You guys okay with that? And then we have negative 6 f of 0 minus f prime of 0 plus 2 f double prime of 0, and then close my bracket. Let's plug in what I know. So we have 1 times negative 6 times, what is f of 0? 2? 2? And then we had f prime of 0 was negative 3, so could I write plus 3?
Yeah.
Okay, then I have 2 times f double prime of 0 was also 0. And all that, if you compute, it's going to give you negative 9. So let's see what that means in terms of our local maximum. So write out the following. We know g prime of 0 is equal to 0 according to part C. This means when your slope is 0, it's either I have the maximum or a minimum, correct? If our double prime is equal to a negative number, is it concave up or concave down?
Concave down.
Concave down, so is it a local minimum or a maximum?
Maximum.
So we have a maximum right here. So here's our justification. G has a local maximum at x equals 0 for 2 reasons. Because g prime of 0 is equal to 0, and g double prime of 0 is equal to negative number. And I guess if you want to be specific and write negative 9, that's fine. But if they see your work up here, it'll be justified.